Okay, welcome back. This is Mr. Hassan's Maths channel. I'm now answering question 11, part B, from the February-March 2024 paper of Pure Mathematics, paper 1, variant 2, from the 9709 Cambridge A-level. And now we have part B of this question. Part A involved differentiation. Part B here, we're asked to find the area of the region bounded by the curve and the line segment AB. Now, the line segment AB is basically the x-axis. So they could have said and the x-axis, and it's the same thing. Okay, and so basically what we have to do is we have to find this area between the curve and the line. Now, in order for us to do that, we have to integrate the function y with respect to x, but between the limits of the x coordinate of a and b. And that will be the area of this section, which is enclosed between the curve and the x-axis. Now, for us to do that, we have to know the coordinates of a and b, which we haven't been given. And we know that the coordinates of a and b are on the x-axis. So on the x-axis, we know that y equals 0. So I have to solve the equation 2x to the power of negative 1/3 minus, let's read that again. 2x to the power of negative 2/3 minus 3x to the power of negative 1/3 plus 1 equals 0. Y equals 0. And when I solve this for x, I will find the 2 points at which this curve crosses the x-axis. Now, what I can see here is that x to the power of negative 1/3. If I square it, I'm going to get x to the power of negative 2/3, because when you raise a number raised to a power to another power, you multiply the two powers. So x to the power of minus 1/3 to the power of 2 will be x to the power of minus 2/3. So I can think of x to the power of minus 1/3. I can think of it as, for example, the letter u. Therefore, x to the power of minus 2/3 would be u squared. So this makes this like a disguised quadratic. So writing this in terms of a disguised quadratic just makes life a bit simpler for us in terms of being able to think about how to solve it. So this is like 2u squared minus 3u plus 1 equals 0. When I've found u, after solving this quadratic equation, I can then replace u with x to the power of minus 1/3 and continue. So now this is a type of question where we have to split the middle term, which I like to do in my own little way. My students call this the window method, the ones that actually like to do it. So I have 2u squared plus 1. So I put the first and the last term in these two positions. Then I say to myself, I know that these two numbers here must multiply to give me the same as those two numbers. It always gives you the same product. So the product that I'm looking for is 2u squared, and the sum is always the same as what's in the middle here, which is negative 3u. So what numbers multiply to give you positive 2u squared, and they add to give you minus 3u? Well, it must be negative 2u and negative u. And multiply them together, you get 2u squared. You add them, you get minus 3u. So now we can think about taking a factor from any of these rows or columns. For example, if I look here, what's common between these two is 2u. And then I can then fill in the rest. I know that this number here is a result of these two multiplied, so that must be 2u times u. This number here is a multiple of is basically the product of these two. So 2u times minus 1. And the number here, this number minus u is a product of u times something here. That must be minus 1. So you end up with 2u minus 1. So this is one of the products up here. And this is the other product down there. So we end up with 2u minus 1 times u minus 1 equals 0. So we're left with either 2u minus 1 is 0 or u minus 1 is 0. So u is equal to a half. Add 1 and divide by 2, or u is equal to 1. So therefore we can say x to the power of 1/3, x to the power of minus 1/3 is either a half, or x to the power of minus 1/3 is equal to 1. Now to solve this, what I can do is I can think of this as its reciprocal, which would be x to the power of 1/3. So this is going to become 2. The reciprocal of x to the power of 1/3 is x to the power of 1/3, and the reciprocal of a half is 2. We could have done it or thought of it the other way. We could have said this is like 1 over x to the power of a third, and this is like 1 over 2. So these two are equal to each other. You can think of it like that. Similarly here, the reciprocal of 1 is 1. The reciprocal of x to the power of minus 1/3 is x to the power of a third. So we end up with this. Now, to find x, I need to cube both sides. So x is going to be 2 cubed, and x is going to be 1 cubed. So x is going to be 8, and x is going to be 1. So now I know that this is the x1 of a is 1, and the x1 of b is 8. So now I have my limits, which I'm going to use for this integral. So I'll bring this equation down so I can see it a bit clearer, so I don't make a mistake. And I know that now I want to integrate this. Okay, and I have 2x to the power of minus 2/3 minus 3x to the power of minus 1/3 plus 1 with respect to x. Now, if I put 8 here and 1 here, what's going to happen is, because this is underneath the x-axis, it's going to give us a negative area, right? And it says find the area of the region bounded. So area should really be positive. I could do this, no problem. My answer would be negative, then I'll say area equals positive, that whatever. But if I switch the limits around, then that's going to give me a positive area. So any area which is underneath the x-axis, if you switch the limits around, put the lower limit on top and the bigger limit underneath, it will give you the opposite side. It will give you a positive answer. So I know it's below the x-axis, as we can see. So I know that if I use 8 and 1, top and bottom, I'll get negative area. But now if I switch them around, I'll get a positive area. So that's, sensible to do that. You don't have to. It's fine if you don't. So now once you start integrating, you don't write the integral sign. So I'm going to start integrating now, so I'm not going to write the integral sign. A lot of people make that mistake. They keep writing integral all the way to, after they've already integrated. No, you don't write the integral sign. You're going to have your square bracket, and you're going to have your limits at the end now. Oops, I switched them around, so it's going to be 1 and 8. Okay, and you don't have the dx anymore. You just integrate this. So now to integrate, we have to add 1 to the power. So 2x to the power of minus 2/3 plus 1, minus 2/3 plus 1, in case you're not very good at fractions. Now remember, 1 is 3 over 3. So minus 2/3 plus 3 over 3 is going to be 1 over 3. So that's 2x to the power of 1/3. And then x to the power of minus 1/3. Okay, sorry, we add 1 to the power, then we divide by the new power. Sorry, divide by the new power. So you add 1 to the power and divide by the new power. Forgot about that part. And here you're going to add 1 to the power, so you're going to add 3 over 3. So this will be minus 1/3 plus 3/3. That's going to be 2/3. So you're going to have this will be minus 3x to the power of 2/3 divided by 2/3. Okay, divide by the new power. And then a constant term just gains an x, so it's become 1x. We can just write that as x. Before I put the values in, I'm going to try to simplify this a little bit. So you know that when you divide by 1/3, you multiply by 3. You multiply by the reciprocal. So 2 divided by a third is like 2 times 3. That's going to give you 6x to the power of a third. And here, again, 3, there will be 3 times the reciprocal, 3 over 2, which is 9 over 2. So you have minus 9 over 2, x to the power of 2/3, and plus x. And now you have your limits, 1 and 8. So now we can put those numbers in. And what I would like to do here is to write this in a slightly different way first. This is like 6 times the cube root of x minus 9 over 2 times the cube root of x squared plus x, 1 and 8. And now I'm going to put the limits in. So when I put 1 into here, it's going to be 6 times the cube root of 1 minus 9 over 2 times the cube root of 1 squared plus 1 minus, then I'm going to put 8 in here, so it's going to be 6 times the cube root of 8 minus 9 over 2 times the cube root of 8 squared plus 8. So let's see what that gives us. Okay, that's going to be 6 minus 9 over 2 plus 1 minus, that's going to be 6 times the cube root of 8 is 2, that's 12, minus, that's 9 over 2 times, now the cube root of 8 is 2, 2 squared is 4, so it's 9 over 2 times 4, 9 over 2 times 4, which gives me 18, all right? Okay, and then I'm going to have plus 8. Okay, 9 over 2. That's right. Yep. So now I'm going to have 6 plus 7. 6 plus 1 is 7. 7 minus 9 over 2. That's 14 minus 9 over 2. That's 14 over 2 minus 9 over 2. That's 5 over 2 minus, and I'm going to have 12 plus 8, which is 20. 20 minus 18 is 2. 5 over 2 minus 2, that's going to be 5 over 2 minus 4 over 2, which is 1 over 2. So we can say the area is equal to 1 over 2 square units. So there's the answer for 11 part B. So this last question actually takes a bit of time, part A and part B, because mainly of these indices and stuff. Now, if you did have time at the end of the exam to check your answer, right? You can check your answer. If you really wanted to make sure that you did the right thing, you can take your equation here, all right, and you can actually use your calculator to check your answer. If you really wanted to, be sure that you did, in case, because it's easy to make a mistake, right? And as I actually don't have the mark scheme for this yet, when I'm making this paper, the mark scheme hasn't been published yet. So I'm going to just do this also to check to see if I've done it correctly, and let's see what happens. So you can use the integral function here on your button, all right? You can't take a calculator in which can do algebraic integration. So it shouldn't be able to give you this expression that I found here, but it should be able to give you the numerical integration. That's not a problem. Okay, that there's no problem if you do that, because if you just write down the answer in the exam, you won't get any marks for it. Okay, for this type of question, you have to show that you integrated. So let's just do this. You have 2x to the power of minus 2/3. So I'll put minus, and I'll put a fraction 2/3. Okay, and then minus 3x to the power of minus, and again fraction 1 over 3 this time. 1 over 3, whoops, 1 over 3. And then I'm going to have plus 1, plus 1. I'll close the bracket, then I'll go to the lower limit, which we use the lower limit as 8. Okay, and the upper limit is going to be 1. Now press equals. It might take a little bit of time. And you see we got a half. That's exactly what we got. So we know, we can rest assured that we did the right thing in getting this answer. Okay, so that's one of the advantages of, you can use the calculator to check, but of course, if you don't show these steps, you won't get the marks. Yes, you have to show at least that you integrated, that you put the numbers in. Okay, maybe if you can go from here to there, or even from this stage where you put the numbers into there, that's fine. I put a bit more steps there, better. So there's the answer to this question. Other questions from this particular paper can be found in the playlist that will appear over here. This is the end of this paper now. So all the other questions are answered, and they are in the playlist that you'll find in the link over here. Other questions involving integration from P1 of Cambridge can be found in the playlist that will appear. Its link will be here. The playlist for my work on integration from P1 of Edexcel and P2 of Edexcel, which corresponds to the P1 of Cambridge, will be found in these two playlists as well. So you have lots of different questions to look at. Thank you for watching, and see you soon.